Hello everyone and welcome to this GLA homework view video for Block 2, Week 2. This is the maths video where we're running through all the maths homework. There'll be another video that goes along for the English. Just as a reminder, this is the week where as part of the homework you need to make sure any of the books that are not going to be part of your lesson material should be taken out of your bags and kept at home. It's not good for your backs to be carrying around all these old books, but also it is confusing, so I would also recommend any old homework sheets from Block 1, any spelling sheets from Block 1, any material that you don't need is certainly not thrown away, but instead taken out, put somewhere safe, perhaps in a folder, and kept at home, because I would advise quite strongly that the only things in your teacher bag are what you need for the current lesson. And because we're going into Block 2, there's now all the homework will have been done in these books, so you don't need to bring back those books. And that does, of course, also mean now is the perfect time, if you do need extra material, you do need any extra work, you've gone past the Euclid and you're still hungry for more, perhaps in the holiday, to try and finish off those Block 1 books and get the maximum value for them. So today we're going to be going through the actual homework. Let's have a look here. It's week 2. We're looking primarily, I believe, now at the maths book at the top, which is the Minecraft one, and a little bit of online. There is some no-nonsense in the Euclid if you have time to get on there, but don't worry, because this can always be done in the holidays that are coming up. Let's just remind ourselves what the online homework looks like. So remember, please, it's under the maths. And today, guys, a bit of a unique situation. Obviously, we are just focusing on the multiplication side of things. Just be aware, within these questions, you may find some multiplication and division. My advice for this is please simply skip the division questions and get the maths questions done. That might mean you're only getting 5 or so questions per go, but that is absolutely fine. We just want you to focus on multiplication. And really, these questions are lovely because you'll see some multiplication questions where they're quite wordy, and it's just a good one to have a little look through and see if you can pass what they're asking and what's going on. Next week you're going to revisit this exact same setup for the online, and you're going to do the multiplication and division together. But we did think, why not get a chance to look at the multiplication in action and see the various ways that they ask these questions. So that's the instruction for this one. So again, you may want to do a couple of attempts and just literally skip the divisions. If you want to give them a go, you can, but please don't spend too much time, especially if you're not sure about division, because that is going to be the content of next week's lesson. So just hopefully that's clear. So really I should underline this. I just want you to try and answer the multiplication half. And that means if you're only getting sort of 5 out of 10 because you're only doing half the questions, that's absolutely fine. Okay, everyone, let's jump into what we're going to be looking at today. So in the Minecraft maths book, it's going to be the mental maths, pages 24 and 25, and then the multiplication tasks on 26 and 27. Let's start straight away with the mental maths on page 24. So obviously with these, there's a whole load of ways to do mental maths questions, and it's kind of unique to you and what's done, and what your best method for doing these questions is. So my advice would be, obviously, as I'm going through and saying these things, if you have a slightly different way of doing it, that's absolutely okay. There's often quite more than one way to get to the answer. And so, for example, here, their method is to think about what these numbers actually mean. So they've said 0.07 is the same as 7 divided by 100, which means you can split this into, 7 over 100, the fraction, which is 7 divided by 100. And so when they're doing 0.07 times 4, that's like saying 7 divided by 100 times 4. And what I've done that's quite clever is they've swapped the order, because when you're multiplying and dividing, you can do it in any order you want. They've decided to do the 7 times 4 bit first, and then divide by 100. So they've done 7 times 4, which is 28, then divide by 100, which is 0.28. And that is the correct answer. Now that's only one way of thinking about it, or one way of doing it. There are other ways as well, and I may go through a variety of those, and it's important that you know whatever you do with school, it's allowed, it's fine, and if there's other ways that you think about it, or even you just know the answer, that's completely okay. Right, let's jump into it and start jotting down some answers. So to begin with, whenever we're dividing by 10 and 100, we're just going to think about moving the decimal back and forth. That's often the easiest way of doing it. I tend to think about the decimal, or moving past the decimals, being better than just adding or removing zeros, because you'll see in question A, there are no zeros to have. So it's a bit easier, or a bit more universal to think about the decimal. So in this case, dividing by 10 needs to make it smaller, and the decimal needs to slide up one space. So it's going to be 24.5. Timesing by 10 does a similar trick. We're going to move the decimal away one. So if this is currently 51.0, and we move it down one space, that's going to now become 510. Now, I'm not going to write it out for all of these, but that's the process we're doing of sliding and moving the decimals up or down. So here, we're going to move the decimal 2 spaces, so that's 1.56. For here, we're going to essentially just be adding on 2 zeros for 1600. This one, the easiest way to do it is to think about 81 divided by 9, which is 9, add the 0, because it wasn't 81, we divided it, was 810. So the answer is 90. For this one, the easiest way to think about it is 5 times 3 is 15, but then this is 10 times bigger, so we add a 0, and this is 10 times bigger, so we add a 0. We're adding on the 2 zeros back on again. For this one, we want to think about 18 divided by 3, which is 6, but then we had an extra 0, so our answer is going to have an extra 0. With this one, 24 divided by 6 is equal to 4, but of course there are 2 extra zeros. This isn't 24, it's 2,400, so we add the 2 zeros back on. So hopefully you can see by adding or removing zeros makes it nice and easy, makes it much faster. Right, these are a bit more decimally that we have to do. So same process though, when we divide by 10, we're going to move the decimal down one space, so 0.51. When we times by 100, we're going to move the decimal up 2 spaces, so 598. Dividing, we're going to move it down 2, so we move it down to here, so 2.619. When we times by 10, we're going to move it up 1, so 90.63. Dividing by 10, it goes down, so 0.207. Times by 1,000, we're going to move it up 3 spaces, so 604. And guys, you can on here if you want to add in the little bumps to show the journey of where it ends up, or if you're happy, you can just do it in your head. It's entirely up to you. So don't forget the decimal where it doesn't show it is here, so we have to move it back 3 spaces, so 1, 2, 3, so it's going to be 0.431. And finally we move it up 2 spaces, so 1, 2, so it's going to end up there, giving us 7.8. Right, on to the next page. I hope that was clear. If you do need to pause the video here to just jot down the answers, that's a-okay. Ooh, for these ones. So what times 100, so what when made 2 decimal spaces bigger equals 560. Well, if I go in reverse and move it back 2 spaces, I think you'll find 5.60 or 5.6. You could write either, they are the same thing, but the reason I've written the 5.60 is easy for me just to check it now. I'll be like, oh yeah, look, if I move it up 2 spaces, I end back where I started with the decimal here. So that's why if you do see me adding in extra zeros, it's just so I can sort of confirm I've definitely got it right. That, don't forget, is a comma, so that's 1,356. So that means the decimal is here, so dividing by 100 is going to move back 2 spaces. It's going to give me 13.56. Something divided by 10, well, 340 divided by 10 equals 34. What divided by 1,000? Okay, so this is what we start with, needs to be 1,000 times bigger than this. So moving up 3 spaces, the decimal should now be here. So that's 7291. Then the decimal point, also known as 7,291. Something times 100 is this. We need something that's 100 times smaller than this. So moving the decimal back, we've got 0.478. And what divided by 100? So we need something 100 times bigger than this. So that's going to move it here and then here. I can add in the 0 to think about where the decimal will end up. So we should have 24730. Now the nice thing about all of these questions is of course you can check. So if I look at that last one, F, that seemed a bit of a difficult one. So if I wanted to just check my working, let's imagine I was in the test and I had some time left over, I could now actually do the sum and try dividing 24,730 by 100 and see if it ends up where it should be. So if I was to move it decimal back 2 spaces, move it here, that would be 247.3. So I'm not suggesting you have to do it for all of these, but certainly if you weren't sure about any of the questions, you absolutely could do the sum in reverse as a lovely way of checking, just to make sure you're absolutely on track and it's all going really well. Right, a worded question. Number 4. Rosa chips away 1 piece of stone with a mass of 0.5 kilograms. What is the mass of 7 pieces of stone? So that's going to be 0.5 multiplied by 7. And the way I'm going to do this is I'm going to think about 5 times 7. 5 times 7 is going to be 35, so I might just do this underneath. So 5 times 7 is 35. But the way I'm going to think about it, the difference between 5 and 0.5 is that our answer should be 10 times less, or dividing by 10. Which means if I divide this by 10, I should get the same answer. So my answer is going to be 3.5 kilograms. Right, last few questions. Question 5, all very, very similar. So we're going to be doing 6 times 7 instead, and the reason we do 6 over 7 is a lot easier to think about, that's 42, but our answer should be 10 times less than 42, because bit 0.6 is 10 times less than 6. So if this equals 42, our answer is 4.2. Now for these, I don't mind if you want to write out the simplified one on top and then do it down, or certainly the simplified answer and then put it down. I think that's what I may do just for clarity. So here I'm going to do 9 times 4. Great trick with 9 times table. We'll do 10 times 4, which is 40. Take 4 away, which is 36. Nice little trick. But again, 9 is 10 times too big, so I'm going to have 3.6 as the answer to this question. 3 times 8 is 24. It's going to be 10 times too big, so I want to have 2.4. We'll write it out properly. 3 times 8 is 24. That's our answer. This one, 5 times 4 is 20, but now the difference between 5 and 0.95 is 100 times different, so we've got to divide 20 by 100, so that's 0.20. If you look, the decimal place has moved 2 spaces up, because we divided it by 100 this time. 9 times 8, same trick. Do 10 times 8, which is 80, take 1 8 away, which is 72. But 72 is 100 times too big, because this number, the difference between these two numbers is a difference of 100. So divide 72 by 100, and 0.72 is the answer. 7 multiplied by 8, like before, that's my favourite number, 56. And 56 is too big, it's 100 times too big, so we're going to divide it by 100 to get 0.56 as the answer. And then finally, these ones are a bit difficult because it's in reverse. So the way I'd think about it is, for this one, I'm going to think 7 times what equals 84. That's the easiest way to do it, to sort of put it into the times tables we more readily recognise. In this case, it's actually 7 times 12. And now we just have to think, well, is 0.7 times 12 going to be 10 times less than 84? And I think you'll find out it is, that looking here, the difference between 84 and 8.4 is 10 times less. It's a division by 10. So I think 0.7 times 12 does give 84, so we've got our answer. So again here I'm just looking at how do we go from 6 to 54? Well, I think it's going to be a bit like the trick with 9 times table. Spoilers, it is times 9, because I can see 6 times 10 is 60, minus 6 is 54, so that's 6 times 9. But again, let's just check, is our answer 100 times smaller than it is? Yes, it is. So from here to here, dividing by 100. So you can be pretty confident my answer here is going to be 9, because 0.06 is 100 times less. This answer should be 100 times less than 54. Guys, that was really good. I hope that was useful. Again, with these, the more mental maths you can do, obviously the faster it's going to be in your test, which is brilliant, because it will give you extra time to either do more questions or to even better check more questions, which we absolutely love and we know is so valuable. But if for whatever reason you can't do them, you have to make a couple notes, like I've done here with a few of these, that's also fine. But just really the golden rule, the secret is you want to do the minimum amount of working while guaranteeing you get it right. So I would say mental math is brilliant, but not if it causes mistakes. So if ever you do come across a question where you're worried it's going to be a mistake, you can always write it down if you need to. But equally, the more mental math you practice, the more time you're going to save. On now to page 26, which is written multiplication. There's quite a few ways, remember, for doing written multiplication. Different schools teach different methods. I'm absolutely okay with everyone using whatever method they want, really, for the homeworks. But the one thing I do just like to make everyone aware of, or let everyone know about, is that the best multiplication method is the one that you get the answer right most frequently. So there is an element of time saving and speed that's important, but if you find one method works 1,000 times better than the others, that is probably the best method to use. So just be aware that although we want you to be speedy and fast, the most important thing is to be consistent. So if you've got a method from school that works, that's different to any of the methods I show here today, and it works for you and it's perfect and it never ever goes wrong, well, that's absolutely fine. Although that doesn't mean that it's not worth learning other methods as well, because it all helps deepen your understanding. Right then, let's jump into it. So there are 28 books in the library. It's 28 sections. Each one holds 36. So that's going to be 36 multiplied by 28. Actually, I think I'm going to move these over here just so there's oodles and oodles of space. So to start with, I'm going to show you a column multiplication. For this, I'm going to do 8 times 6, and then we're going to write the answer underneath, and we're going to sort of carry them. But I'm going to just put this line in here just to give me somewhere to put my carried numbers. So 8 times 6 is going to be 48, so I'm going to carry the 4 tens and write in the 8 units. 8 times 30, I know we can think of it as 8 times 3, but actually the answer is 8 times 30, which is 240. That 240, we're going to add the 40 from before, which is going to give us 280. So this is why the 2 goes in the 200s column here, and the 80 goes in the tens column. So I know you may just think 3 times 8 is 28, but actually the reason we're putting these in the columns is because it's a 280. Right, and then there's nothing to 8 times 0 is 0, plus 2 means we've got 200. So to start with, 36 times 8 gives us 288. On to the next row. Ooh, that should really be in black. So for this one, we're going to do 20 times 6. There's two ways that schools will teach this. Some schools will just teach you automatically, and they never really explain why, to just put a 0 here on the next row. I'd rather teach you why. The reason is this 2 is not a 2, it's a 20. Just the 20 is sort of hiding behind the 8, you can't see it. And so the reason we put this 0 here is so that you can, when you just say 2 times 6 is 12, and write it like this, what you've actually done is 20 times 6, and 20 times 6 is 120, and if you look, what you've written in with that 0 there is 1 in the hundreds column, 2 in the tens, and 0 in the units, which is 120. So I don't mind whether you just put the 0 in, but I think it's nice for you to understand why it's going there, and it's because that's actually a 20. And so that's when it makes your answers then all work out. And then what it means is we could just say 2 times 3, but actually what we're really doing is 20 times 30, which is 600, which means when we add the 100 from before, we end up with 700, and that's why we're actually writing it in this column, and I hope that makes sense. Now that we've done 8 times 36, which is 288, and 20 times 36, which is 720, we need to add them together. I tend to put a little plus sign and even underline it twice just to make it remind myself that I'm obviously doing something different. We're now going to add these numbers up to get our answer. So 8 plus 0 is 8. We've got 80 plus 20 is 100. And then we've got 200 plus 700 plus 100, which is going to be 1,000. So my answer is 1,008. I think that's the final answer. So let's drop that in. 1008 books. So that was one method of doing it, and I think that's a totally appropriate, sensible method. The next question actually gets you to do it in a different way, and it's quite nice just to see the other options. So Riza tries to work out the total number of pages in the books from a bookcase. She starts filling in this multiplication grid. So this multiplication grid is one method. Fill in the empty boxes. So the way the multiplication grids work, you split the numbers up along these sort of axes here, and then you write in the things they make and then add up everything in these boxes to get a total. If you've never seen a multiplication grid before, don't worry, it's not something we normally recommend massively at Teach It Right, just because the multiplication grid tends to involve the most writing and therefore is a bit slower. But as I said, if this is what you use at school and it works perfectly, that's okay. But equally, if you can learn to use the column multiplication because it is a little bit faster, it's probably a good idea. That said, there's no reason why we shouldn't understand how both works. So in this case, we need to know 6 times something equals 420. Well, 6 times 7 equals 42, so timesing by 70 should add an extra 0 on. So now I already know what we've got on this grid. And finally here, we've got 4 times something equals 12, or 4 times 3 equals 12, but we're going to get a 0 and a 0 from here, from the 400. So we need one extra 0 to get to 12,000, so that must be 30. And this is now the grid. And so the actual calculation that she's done is 36, because we know how many books there are, so 36 multiplied by 473. And that's like the starting equation that would have been turned into this multiplication where you split up into the 400, the 70 and the 3, and the 30 and the 6. And so now we've got to work out all the answers. So here, the 1200 came from 400 times 30. Now we're going to have 70 times 30. So also 7 times 3 is 21, plus a 0 equals 2,100. 3 times 30, well, that's 9 plus the 0, 90. 400 times 6, well, 4 times 6 is going to be 24, plus the 2 zeros from the 400, 2,400. And then finally, 3 times 6, nice and easy, is 18. And then so the way it works now, everything in blue, or that was already written here, so all of these boxes we're going to add together. And so whether you do it in your head or not is up to you. I think probably for demonstration, I'm just going to write it down. So you've got 12,000, then 2,400, 2,100, 420, 90 plus 18. So 0,000,008. We've got a 2 plus 9 is 11 plus 1 is 12, so carry the 1. We've got 4, 5, 6, 7, 8, 9, 10, so another 10. We've got 2,000, 4,000, 6,000, so 7,000, and then just the 1. So my final answer for 36 times 473 is going to be 17,000. Write it down here, 17,028 pages. Which sounds about right for an entire bookcase. So for these questions, it's already been set up for you in long multiplication, so I think we're just going to whiz through and see how we do. So 2 times 6 is 12. Actually, for these, I like to add in an extra bit because that's where I put my remainder, so I'm going to preemptively do that. Again, you can always do that if you need to as well. Match the same colour. Okay, so we've got 2 multiplied by 6 is 12, so write the 1 and the 2. 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10. Since there's no other numbers, we can write it there. Easy enough. Now we want to say 3 times 6, but it's not. It's 30, so we can add in the 0. And now we can say 3 times 6 is 18, even though we really know it's 30 times 6. Same idea. There's the 1 and 8. 3 times 2 is 6. Already it's 30 times 20, but again, we can say it now. 3 times 2 is 6, plus 1 is 7. And then finally, 3 times 5 is 15, which we can write in at the end there. Now we have to add them together. 2, 5 plus 8 is going to be 13, so 1 and 3. 0 plus 7 plus 1 is 8. 1 and 5 is 6, plus 1. So I think we've got 526 multiplied by 32 is equal to 16,832. Perfect. On to the next one. So for this one, same process. We've got 8 multiplied by 6. 8 multiplied by 6 is going to be 48, so let's write that there. We've got 6 multiplied by 7, which is going to be 42, plus the 4 is 46. We've then got the 6 times 4, which is 24, plus the 4, which is 28. And 6 times 1 is 6, plus 2 is 8. So 8,886 for that first part. Again, we can't say 2 times 8 is 20 times 8, so we've got to add the 0 in. Now we say 2 times 8 is 16, so 1 and 6. 2 times 7 is 14, plus the 1 makes it 15. 2 times 4 is going to be equal to 800, plus 1 is 900. And 2 times 1 is 2,000. So 29,560. So let's just add these together. 8 and 0. 6 and 6 makes 12. 8 plus 5 makes 13, plus 1 makes 14. 9 and 1 is 10, plus 8 is 18. And 2 and 1 makes 3, so 38,428. So for this one, slightly different, it's got a decimal. My recommended method would be just to pretend the decimal is not there until the end, where we might modify our answer by dividing it by 100. So if we consider the difference between 45.26 and 4,526 is a difference of times and dividing by 100. So essentially we've times the answer by 100, and then if at the end we divide our answer by 100, we'll end up back in the same place. So that's my preferred approach, because otherwise it can get very complicated with where to line up decimals and all sorts of things. So you'll see what I mean. So again, for now, I'm going to treat this as if it was 4,526 times by 24. I think this is my preferred method of doing it. So let's quickly whiz through. So 4 times 6 is 24. 2 times 4 is 8, plus 2 is 10. 4 times 5 is going to be 20, plus 1 is 21. And 4 times 4 is 16, plus 2 is 18. That's the first part. Then 2 times 6, we're going to add the 0 in if it's 20. So 2 times 6 now is 12. 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10. And 2 times 4 is 8, plus the 1, 9. Then if we add our numbers together, we've got, oh, actually that doesn't really clear, is that a 6 or is that meant to be an 8 or 0? I think that's meant to be a 10, let's just check. So that's going to be 4 times 2 plus 2, yeah, that should be a 10, sorry, make sure my own handwriting looks a bit neater. There, 0. So now 4 plus 0 is 4, 2 plus nothing is 2, 1 plus 5 is 6, 8 plus nothing is 8, oh, and then 1 plus 9 is 10. So we've got a whopping great number, and obviously this is way too large for what we've been doing so far, but this is where we have to remember the final step. We've multiplied a number that's 100 times bigger than it should have been, so to get our actual answer we need to divide this by 100. So if we do 108,642 divided by 100, we're going to move the decimal back 2 spaces, which means the decimal's going to be here, so my actual answer is 1086.24. And that would probably be my recommended way of working these out, as long as you can remember that step of we're essentially timesing this top number by 100. So to get back to our answer, you've got to divide this answer by 100 to get back to the true correct answer. But that way it just means you can ignore the decimals and don't really have to change your method at all. So that's certainly my preferred way of handling these ones. Okay, everyone, on then to the next page, which is page 27. In pounds and pence, a stack of bricks costs 7.32. How much does 25 cost? So guys, exact same thing. So I'm actually going to set this out using the same method. So 732. Actually, this is an even better example because it's almost like I'm transferring into pennies, multiplying the pennies, which hasn't got any decimals in, and then I'll put it back from pennies to pounds in at the end. That's kind of a lovely way of doing it. So 732 times 25. I'm just going to remember at the end, whatever my answer is in pennies, I'm going to convert it back into pounds, and the way I'll do that is by dividing it by 100. So I've already sort of pre-planned whatever my answer ends up being. That's going to be my final step. The reason for that is they want it in pounds. Okay, so let's just add in my lines. This is where we're going to add up. This is the one, this is the part here that we're going to convert into pounds. Okay, 2 times 5 is 10. 5 times 3 is 15, plus 1 is 16. 7 times 5 is going to be 35, plus 1, 36. It's not a 2 times 2, it's a 20 times 2, so let's add in the 0. Now it's 2 times 2, which is 4. 2 times 3, which is 6. 2 times 7, which is 14. Add them up, 0 and 0. 6 and 4 is 10. 6 and 6 is 12, plus the 1 is 13. And then 3 plus 4 is 7, plus the 1 is 8, plus the 1. So we would have 18,300 pennies, but to turn that into pounds, that's going to be dividing by 100, so moving it 2 spaces back. So I make that 183 pounds, so 732 times 25, which hopefully makes sense to everyone. How the method works, you sort of imagine it like it's, so you've made it 100 times bigger, so at the end you need to make it 100 times smaller. Use long multiplication to work this one out. Okie dokie, I'm going to set it up here just with more space. 6, 8, 4, 7 times 74. And just plan it out. Make sure I've got plenty of space. This is where we're going to add. And let's get cracking. So 4 times 7 is 28. 4 times 4 is 16, plus the 2 is 18. 4 times 8 is going to be 32, plus the 1 is 33. We've got 4 times 6 is 24, plus 3 is 27. Now, again, I want to say it's 7 times 7, but it's not, so I need to add in the 0 in because it's a 70. 7 times 7 now we can do though, which is 49. 7 times by 4 is going to be 28. Plus the 4 though, 28 plus 4 is 32. 7 times 8 is going to be 56. Plus the 3 is 59. And then finally, 7 times 6 is going to be 42. Sometimes people find this one hard. If you do 5 times 7, You only have to add what, which is 35. People find that one quite easy. You only have to add one more 7 on to get to 42. That's a nice way of doing it. But don't forget we've got the 42 plus the 5 that we carried, and 42 plus 5 is going to be equal to 47. So I have to just put a bit more space here. We need to have the 4 and the 7. Should have drawn that a bit bigger. Just move that down. Okay, so now we need to start adding things together. 8 plus 0. 8 plus 9 is going to equal 17. 2 plus 3 plus 1 is 6. 7 plus 9 is 16. 2 plus 7 is 9, plus the 1 is 10. And 4 plus 1 is 5. So I think we've got 506,678 is my answer. And that certainly is a long division. So really well done if you followed that along, if that makes sense. And I would say this is the kind of thing that, not just outside today, but make sure, especially if you haven't quite got these or you find these challenging, make sure you practice questions like this, because this is about the upper end of how difficult they're likely to be. So if you can do these consistently, and you practice one of these or 2 of these every week, over the next month or so, you're going to find you get really good, really fast, and more importantly, really consistent. So there's one final page of questions at the bottom of 27, which are these ones down here. I love these questions because they really test your understanding, because it requires you to fill in the missing gaps. So my advice for these is to sort of work through the process as if you were solving it, but then think about what numbers would need to be there if there's a gap. Well, what I mean by that is, so I'm going to check out this first row first and just go through the 6s and see if I can use that to help work out the top bit, and do the same thing on the bottom row. So to begin with, I'm going to have 6 times 3 is 18. So I would have written 1 and 8. Then 6 times 6 is going to be 36, plus 1 is 37. So you see I'm adding in the carry marks, and that's going to hopefully help me work out what's going on. Then we need 6 times something equals something 7, but that 7 ends up having a 3 left over. And we know that there's also going to be a 2 here. So I think I can use the fact that 6 times 5 is 30, and obviously plus 2 gave me 32 to mean that whatever my answer is going to be something 20, because that's where this 2 came from, because otherwise it would be 30, not 32. So you only get 32 as if our answer ended up carrying a 2. And I also need to remember that I've added on a 3. So I think 24 add 3 will become the 27, and so then I need to do 6 times 4, and let's just check that that works. So if we do 6 times 6, we end up, and plus the 1, we end up writing 37. 6 times 4, we would have done 24, but plus the 3, so 27. And then 6 times 5 is 30, plus the 2, we'd have written down 32. Whew, tough one, that one, but good. Right, let's move on to the second row. So now we need to do something times by 3 equals, well, in this case, remember the 0 is already there, equals something. So what could it be? Well, we don't know yet because there's 2 empty boxes, so something times 3 equals something. What about my next line? We've got something times 6 equals 8. Well, if I go through my 6 times tables, so you've got 6, 12, 18. 18 ends in 8. I'm not sure if there are too many others. 24, 30, 36, 42. So I think I'll try working on the assumption that it's the 18 at least to start with. Then we can always check the 48 one later, because there's only a couple of 6 times tables that actually end in 8. So let's assume it's 18. How would we have made 18? Well, that would have been timesing by 3. So let's go with that. We're going to test out, is it a 3 to start with? And if not, we can always check. We can always assume that if it is 48, it means we'll try an 8 in this spot and see if that works as well. So let's keep going based on the assumption it's a 3. So 3 times 6 would then equal, well, first off, so 3 times 8, 6 would equal 18. So you'd write 1 and carry 8. Then 3 times 4 equals 12, plus 1 is 13. So we would write the 1 and we would write the 3, so that looks good. Then we've got 3 times 5 is 15, plus the 1 is 16. So yeah, I think that explains where these numbers have come from, which then means, going back from the very start, 3 times 3 would have written the 0, and then would have filled in 9. I guess now let's just check, does it all add up? 8 plus 0 is 8. 7 plus 9 equals 16. It's looking good. 7 plus 8 plus 1 equals 16. So we write down the 6 here. We've got then 2 plus 3 plus 1 is 6. 3 plus 6 is 9, and 1. Whew, we got the answer, guys. That is a tough question, but really fun. I like these ones a lot. One thing you can always do if you're ever not sure as well is if you've got the time left over, you could always rewrite out your supposed answer. We've sort of done that. So I've not written that very well. It should really be over here. And actually just do the multiplication. And this is obviously not something I would do if I was pressed for time, but that's a good way of checking it. Let's see, does this match up with this perfectly? I think in this case, yes, it does. Okay, this next one, let's do the same sort of trick. So we've got 7 times something equals something. Well, we can't use that. 7 times something ends in 6. Well, because we don't have, so we've also got 7 times something else ends in 1, because there's not a lot of information for the top row and we're missing the first number, I might actually try and see if I can get away with using the bottom row first to give me some more clues. So obviously 2 twice is 20, so we add the 0. 2 times something ends in 4. Well, there's a very good chance then that could be 2 times 2 ends in 4. Or 2 times 7 ends in 14. Okay, so we've got 2 options. So it could end up in 2 times 2 or 2 times 7. Right, okay, let's keep going. So we've got 2 times something else ends in 3. Ah, well that means it can't be 2 times 2, because 2 times 2 wouldn't carry anything else. But if it was 2 times 7, we'd have written 1 and 4, and then that does carry over. So now I think we can make this work, because 2 times something ends in 3. Well, it could be 2 times 1, but then 2 times 1 wouldn't get 3 here. So I think I've got this. We need to have another 1 carried to get this to go up to be from 2 times 1 becomes 3, which means we need a number here that's going to be 10. So I think if this is a 6, we get 2 times 6, which is 12, plus the 1, which is 13. Then 2 times the 1, which is 3, which is just 2, plus the 1, 3, and then 2 times 3, which is 6. I think we've got it, which now means we can go back up to the first row and do 7 times 7, which is 49. 7 times 6 is 42, but plus the 4 makes 46, so this works. Then we've got 7 times 1, which is 7, plus 4, which is 11. 7 times 3, which is 21, plus the 1, 22. I think we have got it, guys. That is the answer. Whew, that was a tough one. Really, really good questions, though, so really well done to anybody who managed to get those. That actually is then the end of the maths homeworks. Of course, just have a look, guys. There is down here in the You Could some additional topics, so some questions on coordinates and negative numbers. Just be aware, everyone, that for the maths there is some additional material in the You Could, and it may not be things you've seen at school yet. We include it here just really to get the maximum value out of looking through the book. These are things that we will cover throughout the duration of the course, but they're not things we directly have lessons on, in part because most schools will have covered this material. But if there's ever anything you're unsure about and You Could, you're always more than welcome to come in and speak to your tutor about it, and we'll absolutely happily work through it with you if it's something you feel you need. And as I say, a lot of these will also be covered again later in the course as part of questions that we will be doing. Right, everyone, thank you so much for your time and attention. We'll see you on the English video next week for some more. Bye bye for now.